Problem 69, Quantum Mechanics. The question is, let x and p denote respectively the coordinate and momentum operators satisfying the canonical commutation relation. The commutator of x and p is equal to I. In natural units, h bar equal to 1. Then the commutator of x and p e raised to minus p is. Here, we have to find out the commutator of x and p e raised to minus p. We know that e raised to minus x equal to 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial, etc. Also, the commutator of a and bc equal to the commutator of a and b times c plus b times the commutator of a and c. So, what is the commutator of x and p e raised to minus p? The commutator of x and p e raised to minus p is of the form the commutator of a and bc. Therefore, we can say it is equal to xp, the commutator of x and p times e raised to minus p plus p times the commutator of x and e raised to minus p. It is given that the commutator of x and p is equal to I. Therefore, our first term becomes I e raised to minus p. The commutator of x and p e raised to minus p becomes I e raised to minus p plus p into the commutator of x and. Now, what is e raised to minus p? E raised to minus p is 1 minus p by 1 factorial plus p square by 2 factorial minus p cube by 3 factorial plus etc. This is equal to I e raised to minus p plus p times. First, let us separate the commutators. First commutator is the commutator of x and 1 minus 1 by 1 factorial the commutator of x and p plus 1 by 2 factorial the commutator of x and p square minus 1 by 3 factorial into the commutator of x and p cube plus etc. This is equal to I e raised to minus p plus p times within bracket the commutator of x and 1 is 0 minus what is the commutator of x and p, that is equal to I. So, the second term is minus I plus 1 by 2 factorial. Now, let us use the commutator of the equation for commutator of a b raised to n. So, the third term becomes 1 by 2 factorial 2p xp. The third term becomes 1 by 3 factorial 3p square xp. This is because the commutator of a and b raised to n is n b raised to n minus 1, the commutator of a and b. Therefore, the commutator of x and p e raised to minus p becomes I e raised to minus p plus p times minus I plus, again use the commutator of x and p is I. Therefore, the second term is pi. The third term is minus p square by 2 factorial I plus etc. Now, this is equal to I e raised to minus p. Now, let us take I outside. So, it is minus ip times 1 minus p by 1 factorial plus p square by 2 factorial plus p square by 2 factorial minus etc. Now, this is equal to I e raised to minus p minus ip into what is 1 minus p by 1 factorial plus p square by 2 factorial minus etc. It is e raised to minus p. Therefore, our answer is I e raised to minus p into 1 minus p. Therefore, we can say the commutator of x and p e raised to minus p is I times 1 minus p e raised to minus p. Therefore, from the given option, we can say option A is the right option.